Hello friends, good morning. Welcome back to our channel ALPTalks. This is your Lakshmivati. Today we have one guest, Santhosh, with us. Today's our web interview topic is power electronics and its different aspects. We can say what are the different devices are involved in this power electronics, IGBT, MOSFET, and other details like current rating, voltage rating, so frequency, which for which application, which device we are going to use, and UPS. So and some things related to inductor and core, magnetics related, and switching frequency. So he discussed all these topics very clearly. It is very easily understandable to anybody. So if you are interested, if your area is related to power electronics, so it's better to you to watch this video. If you are a fresher or if you are just a college student, you can watch this video for getting better knowledge about power electronic components and all, how things are there, how people are actually using in industry, the heat shrink and all, how we can design cooling. We will provide cooling for the all the magnetics and sometimes these devices, forced cooling, how we will provide it. So all this setup, DC-DC converter, where we will use applications and so many things we discussed in this video. Mr. Santhosh, he is an electrical engineer. He explained all this stuff in clearly. So he is working in Bangalore somewhere in some company. So if you have any questions or comments related to power electronics, if you are doing any project or anything, you can directly message to Santhosh. I am providing his contact details in the description. I hope you will enjoy this video. Please continue for watching. Nice, nice, nice. Yeah, hello Santhosh. Welcome back to our channel, ALP
Yes,
Talks.
sir. Yes, sir.
Yeah,
Good evening,
nice,
sir.
nice. Yeah, good evening, good evening. Yes. Yeah, I'm happy to see you here.
Thank you, sir.
Yeah, I given.
Actually, I'm very happy to talking with you like this on power
Yeah,
electronic fields about these technical discussions and all.
yeah. I think I given very less time to you to you accepted our meeting. Yeah, very nice, nice. Yeah,
Yeah.
just to give a brief discussion about me. 2 months back, I started this YouTube channel for sharing knowledge, sharing whatever knowledge I have, and I am gathering from my friends and all industry experts. Maybe some 3 to 5 years people who are in outside. I am gathering them so that they can share their understandings, their lifestyle, their discussions, technicals, and all, so that it may benefit many professionals who are in colleges and all. So that's the main theme of our discussion actually. So yeah, it's your turn. We want to know because few things about you, so that people are engaging with us for 1 hour, so that they can get better understanding of you, who you are, what is your educational background, professional background, so that they can. It's very good to know.
Yeah.
Yeah,
Yeah.
welcome,
Actually, first
welcome
first of
again.
all, good
So
evening.
yeah, you proceed. Yeah, it's your turn, dear.
Yeah. Thank you, sir. And it is a first of all, it's a very good idea, sir. Why? Because there is in every person there is a in technical there is a miscommunication or misunderstanding. They
Yes,
will think in different ways.
yes,
Like
yes,
these type of platforms, we can create one barrier between these technical things. This is a very good option.
yes, yes,
And
yes, yes.
coming to me, presently, actually, my name is Santhosh.
Mm.
I done my BTech in MVGR College in Vizianagaram. Coming to my native place is in Vizag, it is in Andhra Pradesh.
Yeah.
Coming to technical background, previously I worked as a service engineer in for the HV and UPS installations in 1 year before in
Mm.
2017 to 2018.
Yeah,
And
yeah.
after I think that servicing is a good field, but I need to learn the design and how they are selecting the components, how they are calculating.
True,
So I
true.
came to Bangalore and I got here in Dubas Engineering Private Limited. I'm now presently working as a system design engineer for UPS and DC-DC
Mm-hmm.
converters in R&D
Okay.
department. It is a very good
Oh,
field
okay.
in power electronics. And coming to my company gives me very good platform from the zero where I started as a zero to now I'm giving 30 marks for us presently. Why? Because from completely now I'm dealing with zero to now I'm completely designing the system fully magnetics and the power electronics devices IGBT and the thermal calculations and thermal devices like heat sink and how to
Mm-hmm.
calculate the force rate. These
Yeah.
are the things I'm dealing in the Dubas Engineering Private Limited.
Okay, okay, good, good, good. Yeah, actually, in education we study very less. I can say we don't know the component. We don't. Nobody will teach us. Even though few people will teach, we won't get that much understanding. Yeah, I think oral electronics is the vast subject that is going to be the future in coming future and all. It is the thing. Power system
Yeah, all
machines
are
and all, they are very old component. They are from 100 years. It is same thing. But power electronics,
yeah.
day by day, it's keep on advancing a lot. So how you are feeling about power electronics job? Whatever you have experienced, how things are there before and before that job. Now you are. How is your understanding skills
Yeah,
about the
eh,
visualization?
power electronics. Actually, coming to power electronics, what you said is correct. It is now it is in the starting phase. After in 2017 to it is started.
Mm-hmm.
So daily it is upgrading like it is rising very fast moving compared to power system. These all are very.
Yeah.
I'm not saying low. That is the basics,
Yes.
and
Yes.
now
Yes.
they are improving. And
Yeah.
coming to
Yeah.
educational, in there we read IGBT MOSFET. That is only for basics. IGBT means this one. We're coming to here. What is IGBT? What is how to select? What is the device and all. And coming
Mm-hmm.
to how I'm working with how I'm dealing with power electronics, it is very good. Why? Because I'm working all the components, and mine is my company is dealing with customized product. As per customer, we are designing the unit. Day
Okay.
by day,
Okay.
customer giving this, they are restricting our area of the product. Why? So someone tell that you need to operate system within the 55 degree. They are telling
Mm-hmm.
75-degree. So while
Mm-hmm.
designing these ones, we are facing so
Mm.
many
Hurdles.
challenges,
Yes, yes,
hurdles
yes.
and challenges, and those
Yeah.
challenges we are sort outing by we are in R&D field, so we are sort outing. But
Mm-hmm.
the process of working gives very happiness while designing
Yeah.
or while doing the testing and all.
Yes, yes, yes. When you are able to apply anything what you studied, you will get happiness at all. I think you
Yeah,
will get good
happiness and
sleep also. I can say.
yes, a very good fit. While working in our company, it is very good. Why? Because my
Yeah.
technique coming to, I need to give respect to my people also.
Yes,
I
yes.
don't know
Sure,
in
sure.
other company,
Yeah, yeah, yeah.
the technical lead or technical manager who I have, they are giving full
Support.
freedom. If you want
Mm-hmm.
to test, that is they know. Suppose if I say something, it is a wrong. Also, they know. They will say why it is wrong, why it is correct, why we need to do like this. They are explaining me. Why?
Yes,
Because
yes, yes.
I joined in 2019 in as a R&D in sir UPS design and all. So
Mm-hmm.
presently I have 1 year 11 months experience. But in
Mm-hmm.
1 year 11 months experience, I have a confidence to handle the system. So
Yes,
those
yes,
confidence
yes.
I get from the my team leads and my project in charge, my technical
Yes.
leads. Also, that is
Yeah.
the good thing from my company.
Generally very few cases will be like this because if having good team is very nice for the starting freshers or I mean for to
Yeah,
start our career. If you have very good
yeah,
team like this who support us, okay, let's try and learn little bit. Those kind of things we can see very rare in very big companies. Generally you may not find that much environment
yeah.
because they
That is
failure,
correct.
you generally we don't get, they don't want failure actually. Yeah, here it's
Yeah,
not like failure, but it's a good, yeah, yeah,
it is
very nice.
experience, good
Good
experience.
experience. I think you are in good place, particularly in power
Yeah,
electronics. That's nice, actually.
yeah, sir. That is a
Yeah,
good thing. Here we are handling both. Coming to in future, it is a you all are e-mobiles, like means in electricals only. So
yeah.
we now I'm dealing UPS along with DC-DC. This is the main thing I am handling. I am very happy with that. Suppose
Mm-hmm.
UPS means in some case it is useful.
Mm-hmm.
DC-DC means it some in some case it is useful. But now I'm dealing both UPS and DC-DC. So I think okay in future I have some future about the power electronics and how to deal with these situations like in
Yeah, yeah,
battery chargers or UPS or like SCM static converter modules or like this.
yeah, yeah, yeah. Yeah, generally these things are going to be very much important in coming days. We can say our starting DC is there, DC generator DC. After that, Tesla and all, we are with AC now. Nowadays also AC. I'm thinking in future also it's going to be DC for most, at least
Yeah,
most of the user utilization cases. It may be e-vehicles, or it may be mobile recharging, or it may be most of the places wherever solar these things are coming in nowadays. It power electronics playing major role. Okay, okay.
yeah. Future is on power
Mhm.
electronics only. Why? Because these all sources are we are using. So there should be a extra source like is a solar is a now presently they are saying infinity source we need to use for
Mhm.
the future generation. So
Yes, yes, yes.
all the scientists or all the people is trying to use the solar. So we
Yeah.
need to use solar means we require power electronic components with better futures. Now presently we have some futures, better futures we need to upgrade. So future is only based on the power electronics field only. I think like that.
Yeah, yeah, yeah. That's true. That's true. Yeah.
Yeah.
So let's jump into the little bit topics. So whatever power electronics is there, generally wherever conversion is there, in those areas we will use, right? What to say?
Yes,
Can you
yeah.
explain at which
Wherever
places we will use it?
the power electronics in the sense we can't say where is the power conversion is not there in regularly if suppose DC to DC, that is the
Mm-hmm.
same power with the same,
Yeah.
but
Okay. Okay.
we the power electronics is basically coming from controls. We need to
Mm-hmm.
control the power. This is the
Okay.
main thing of the power electronics. If
Mm-hmm.
suppose it is a 230 AC and input is the output also 230 also, but we
Mm-hmm.
require some control
Mm-hmm.
with
Mm-hmm.
fast, like
Okay.
some coming to, yeah, coming to mechanical switches or
Mm-hmm.
mechanical devices, it requires some
Mm.
time.
Yes,
If
yes,
suppose
yes.
it take in 1 minute it will take 20
Second.
calculations. Then power
Mm-hmm.
electronic device in 1 minute they will do 10 kilohertz switching, like we'll say switchings and all. So the
Mm-hmm.
faster speed in power electronics to this is the main theme of the power electronics. From
Okay.
that origin they generated different type of conversion, they used in different type of conversion different places and all.
Mm-hmm.
Like
Mm-hmm.
see in
Mm-hmm.
our mobiles also so many transistors, these all the devices we're using. Coming to power electronic devices, now all are max on max where we am seeing the all power electronic devices is there.
Yeah, yeah. I think whatever you will see, some power electronic device you can observe. I think
Yeah.
particularly you can observe it. Hmm.
Yes, sir.
Yeah, some other people may see it's like black box. That's it.
Yes. Yeah,
That's
no, all
true.
these guys.
Yeah. Okay. Okay. Mm-hmm. So,
Coming to the,
yeah, proceed, proceed.
tell me. Coming to these in our industry, we are dealing with high power electronics
Mm-hmm. Mm-hmm.
and low power
Okay.
also we are dealing. That is we are giving to PCB team.
Mm-hmm. Mm-hmm.
That is also we are only doing the schematic and how to select the component, how to select suppose how to select op amp, how to select our driver circuits and all. And
Mm-hmm.
I'm in as a like a system engineer, I need to take the more power into the account. So I am dealing with MOSFETs, IGBTs,
Okay.
and that
Okay.
SCR switches and how the
Mm-hmm.
gate triggering should be there. This is the I
Mm-hmm.
am dealing. Now
Okay.
actually this is a satisfying for me that I am dealing with more DCs like 600, 650 DC and 1000 volts DCs. Those
Mm-hmm.
devices also I'm operating like.
Okay, okay, okay. So generally, what is the power rating around? Is this around 500 watts or 1 kilowatt? Generally, what is the power you
Like
are
a
dealing generally?
max I dealt with 120 kV unit, 1 to 120 kV unit.
Mm-hmm. Is this
Yeah.
kV or kilowatt? I mean, I'm not getting
That
you.
that is UPS is 120 kV UPS.
Uh-huh.
And
Okay.
coming to DC, our we are dealing with the 330 kilowatt.
Mm-hmm. Mm-hmm. Okay, okay,
330
okay.
kilowatt also we are dealing. Presently, I am in a project where I'm dealing with 30 kilowatt.
Mm-hmm. Mm-hmm.
That
Yeah.
is in R&D stage. All the calculations, how to components are that is in
Yeah,
R&D
yeah.
stage.
Okay. Generally, these applications, DC applications, where we will use Santhosh, can you explain a little bit application point of view where we need DC areas, why we need those things? Can you explain a bit?
Yeah, this is DC. Like, see, first the main thing of DC is to uh, step down the our battery current, not battery voltage,
Mm-hmm.
voltage of the customer.
Uh-huh.
Suppose customer have some 400 volts DC, but
Mm-hmm.
their components required only 200 volts DC.
Okay.
So there we need required DC. Some
Okay.
of the areas like see regular AC power supply will be there, but in industry any failure should be rectified within microseconds only.
Yeah, yeah,
So
that's true.
there we required power electronic DC systems. How means the AC fails, so our DC should be coming to picture. DC
Yes,
should
yes,
be
yes.
coming to picture means all our designs are worked only for AC. It is designed for AC only. So there we invented DC converters, and again with DC to DC and DC to AC we will convert
Okay, okay.
in,
Mm-hmm.
in, in industrial area. Coming
Okay.
to our regular in homes means we are using inverters,
Mm-hmm.
UPS and inverter. Like in our in C, our mobile charger is also a AC to DC conversion.
Yeah, yeah, yeah.
These all in everywhere. Coming to high, we are going to upgrade means like if now electrical vehicles is coming, that
Mm-hmm.
that is directly first AC to DC they are converting by charging, and they're using DC to DC converters for mobile car charging,
Okay.
electrical vehicles. Like in Bangalore, it is almost all our electrical vehicles is coming. I'm seeing so many things present days. Why? Because electrical car also recently I seen
You
in
launched
Bangalore.
it. Yes, yes. One
Yeah,
model is launched. Yes, I also observed.
yeah,
Okay,
yeah.
okay.
It is very good to see that that is so like this in every field. Coming to the regularly what the people need to use, there also DC converters is like it is in mainly now present in 2018 to 20. In between, industrial is using more DC for the battery chargers, for
Okay.
the
Mm.
uninterruptible power supplies like that.
Mm-hmm. Okay, okay, okay. So these in these battery charges and all, generally what components we will use? Mainly, say, not about triggering circuit and all. I mean, main circuit where
Component.
component. Generally, what we will use?
Yeah,
What
it is
components we are
also there is
using?
yeah there is a two logics is there in that. The rating
Mm-hmm.
of the battery charging, if it is a rating is very high, it is above the
Mm-hmm.
5 kilowatt or 10 kilowatt.
Mm-hmm.
There we will use the IGBT as a component.
Okay,
Why?
okay.
Because IGBT can handle more power, but it has less switching.
Mm-hmm.
Right.
Okay,
And
yeah,
coming to
no.
the yeah, coming to the MOSFETs, that means below the 5 kilowatt devices, we
Mm-hmm.
are using the MOSFET as a switching component. This
Okay.
is the main thing. And while
Mm-hmm.
dealing with the power electronic things, there is a main thing we need to keep in mind is thermal.
Mm-hmm.
Thermal we need to take
Dissipation.
care. Other yeah, dissipation, and we need to take more thermal. Why? Because these
Mm-hmm.
are more sensible to thermal.
Okay, okay.
We are
Mm-hmm.
not giving that much preference for the thermal means device will fail after before MTBFE calculations. We are calculating MTBFE calculations. Okay, suppose the
Mm-hmm.
IGBT or MOSFET will can come 10 years. They given 10 years as a validity. So if you are not taking the thermal safety precautions, it will be only come for 3, and it will give more dangerous to the all the other components in the system. If suppose IGBT or MOSFET failed in the unit means entire system will fail.
Yes, yes, yes.
This is the major components in DC-DC systems.
Okay, okay.
Most of the DC-DC systems is based on the IGBT only. Why? Because DC-DC systems deals with more power rating.
Okay,
And
okay.
coming to, I'm not saying about the driver circuit. In drivers also, we are using 24 volts to 5 volts DC-DC converters.
Okay, okay.
Here we
Uh-huh.
are using MOSFET and flyback power supplies is there. That means we are giving AC 230 volts. Again,
Mm-hmm.
they are that is and where you are using flyback converter topology. There we are using MOSFET. Why? Because there we require 24 volts for only fan supply in the unit,
Mm-hmm. Yes, yes, yes.
LED glows, and
Mm-hmm.
HMI displays. Like that we are using. So there is a low rating, that is we required only below 1 kilowatt. So there we are
Mm-hmm.
using MOSFET, and the
Okay.
advantage with MOSFET is we can go up to more switching, like at so much 150 kilohertz, 200 kilohertz.
Yeah,
We can
yeah.
go by using MOSFET FET
Mm-hmm.
settings.
Okay, okay. Mm-hmm. Those heat sink and all generally which material, Santosh? Aluminum or any other else?
No, regularly we use aluminum. So why? Because we take that much margins in that things. Why? Because we need to take cost into mind while designing or not. So
Mm-hmm.
there we can compensate that heat sink aluminum area by using these margins in the temperature.
Okay, okay. Yeah, generally aluminum is conducting material, right? So it will, I mean, electrically conducting
Yeah,
and thermally it will dissipate betterly. But
yeah.
electrical point of view, is there any losses, extra losses in the heat shrink due to surrounding components and all? Anything is there like that?
No, sir. Due to electric, there is no electrical conductor. Well, because in between any device, what we pasted in,
Insulator,
yeah, we are facing the this one. What we say? 1 second, sir.
vibration pad or something.
Thermal, yeah, thermal pads, thermal pads.
Yeah, thermal
That is
pad.
only, yeah, thermal pad has a more electrical resistance,
Mm-hmm.
less thermal resistance. That is the biggest advantage of the thermal pad. So
Okay.
that is we faced between the our device. It is a MOSFET or IGBT to heat sink, that aluminum heat sink.
Okay. Yeah, I'm thinking that any stray, due to any stray flux or anything, not direct contact, due to some magnetically influence outside, is there any chance of EMF or anything inducing in heat shrink and flowing, current flowing like that? I have that question in my mind. Hello, Santosh? No, I am not able to hear you. I think you were muted. Unmute yourself.
Yeah,
Hello.
now it is okay, sir.
Yes. Now it is okay. I'm able to hear you.
Yeah, that stray flux you are saying that
Mm.
we are giving one coating for the heat sinks,
Mm-hmm.
and that will not affect that much. Suppose you are saying, suppose one conductor will pass above the heat sink.
Mm-hmm.
So due to that
Mm-hmm.
flux around the conductor will results in Q2 losses.
Mm-hmm.
So while
Mm-hmm.
yeah, this will comes into the picture with the low rating device. Why? Because there every volt or every amp is very
Matters.
countable, matters and
Mm-hmm.
all. So we are dealing with high, and we will take that cares by providing the some insulator like normic sheets.
Uh-huh.
This
Okay.
this will take care of the electrical insulation. We can't take care for this flux and all.
Yeah. We can't
So
take it.
it will
Yes.
give very it will take very less wattage also. Sorry,
Mm-hmm.
it will take very less care also for that.
Yes. Magnetically, we don't have any insulation also. Electrically, we can
Yeah.
have. Yeah. Okay. Mm-hmm. For continuation, please watch part 1 of this video. Thank you, friends. Thanks for watching. I hope this discussion helped you a lot. So, I am sure that this discussion will enrich your knowledge to next level. So, if you have any questions or comments, please comment in comment section. I am ready to help you. If you want any new videos or new topics and new topic, please comment in comment section so that I can make content for those also. Thank you. Thanks for watching. Please subscribe to my channel so that you don't miss any of my future updates. Bye bye. Take care, guys.